So today we are talking about regex in Python, right? And they're called regex, regex, and essentially the full name is regular expressions. And I'm also going to talk about the command line arguments, but we may have to go to the next class to do that. So first of all, what is a regular expression? Let's just quickly understand what regular expression is. Why do we need it? And then I'm going to introduce you to the module that regular expression the Python uses for and basically how to use it. So what is regular expression? So let's begin with an example. So let me just fire up the terminal. Okay, suppose we have basically a string containing text of some form. Suppose we have s is equals to universe. If we want to match a particular substring, whether it's present in the string, then we can very easily ask this question using one or the other ways. We can say verse in s, we get it true. We can also find where this particular string is present by just doing this. We can write whatever s dot find verse, and we'll get the index where this substring is present. Okay, so basically, both checking whether the string is present or where the string is present is a pretty easy stuff in Python. However, what if we don't know the target string? This verse, for example, what if we don't know what this target is, but we only know a pattern for it? So suppose there is a piece of text which has a whole bunch of stuff in it, and let's say it has some year in it. Then how can we ask this question whether an year is present inside the string? Right? So we don't know what that year is going to be. It can be, here it is 1991, but it could be 2001, 2013, anything. So, or it can have other stuff. For example, it might have some kind of an email, right? So you can ask this kind of question that this text contains some emails, and basically let's say Himanshu at whatever yahoo.com and some random stuff. So given this text now, given this text, can we ask this question whether this text contains an email address? Not specifically a particular email address, but does it contain any email address? And if it contains an email address, then where is that email address present? And also, if that email address is present, then what is that email address? Right, so we have no knowledge of target that we are trying to look for. Neither we have any knowledge of where the target is. So in this case, what we use for searching is called a pattern, right? We use a pattern to search. Searching with pattern is facilitated by regular expressions. So regular expression is a language which allows you to specify certain string patterns which you can match in some other string. So just by, we all know certain patterns already. For example, suppose that I ask you this question. Suppose take this 192.161.5.201. The question is this an IP address? The answer is yes, it is an IP address. How do we know this? We know this based on some information that we know because we have learned about IP address. What about this? Is this an IP address? This is not an IP address. It looks like the pattern is somewhat similar, but it is still not an IP address. Right? So this one is not an IP address. Right? So specifying this information is what regular expression helps us do. Or you can take a different example. You can write, let's say, something like, let's say, Himanshu at gmail.com. Suppose this is the email address. Or there is another string which is like, let's say, Himanshu at whatever. Right? The second one might not be an email. This one might not be an email. Whereas this one is an email. Right? So what do we inherently know about a certain pattern and how to express it? So regular expressions helps us do that. So in Python, you have a library, and the library for regular expression is RE. So you say import RE. So now we have regular expressions imported. Now this talk is going to be in two sessions, session 1 and session 2. So I'm going to first cover a little bit of breadth. Okay, I'm going to introduce you to some functions and how to look for patterns. And then in the next class, we're going to continue. So, okay, if I mean, there might be some information that if you ask me, I'll probably tell you that we are going to cover in the next session. So let's move forward now in this. So first of all is the regular expression module. In this module, we are interested in three things. The first is a function called a search function. The search function is going to tell us the very first occurrence of a pattern within a source string of some form. So Python has very good documentation on their regular string patterns. So if you just go here, for example, and open the regular expressions documentation, you will just one second. Oh, yeah. Then you will get all the important functionality that is present here, and you can look into it after the class. I'll send you the link. Well, let's go back here. So search, basically it will return the first occurrence of a pattern. The second function that we want to cover is find all. So this returns all the occurrences of a pattern. And there is a difference between the first and the second. We'll talk about what the difference is. And finally, we want to look into the third important function called group. So I'm able to achieve a lot of things using these three functions. So I want to focus on these three functions first. Okay. So let's look into the body of search. Like, how do you do the searching operation? So suppose let's learn by trying things out here. So suppose I'm going to say remodule.search, and how you search inside this is basically you specify a pattern that you want to search and the source in which you want to search. And this will return something that we'll see what it is if this is true. So suppose that, let's just try a hard-coded example. So verse and suppose universe. So we run this and we got that as a reply, we got a match object. That's some kind of a re.match object. And it has something here, and then it has something here. So search returns a match object. This is the important part to remember. This will return a match object, and the match object contains all the information about that particular search that was done. So first it tells you the exact match that was found. So the match was verse. We were looking for verse and we found verse. This is important because in the case of email, for example, you may not be able to say the exact email that you're looking for. You will just say, is there an email present? And in that case, the match will contain that email. So you'll be able to get the exact email that was found. Okay. Then the span. Span contains, you might have guessed, it contains the indexes where this pattern is present. Once again, currently we know that this is a length 5 pattern, and so this is 328. But in the case of email, it can be any length, right? As long as it's permissible length to create the email, that length can be anything. So this returns a match object. What does it return if the pattern is not found? Suppose you have this, then it probably returns nothing. So let's look for n. And n equals none is true. Basically, the search object returns none if the pattern is not found. Whereas in the previous case, if you come here and let's say you look for m is equals to that, m is equals to that, and then you get m, so you'll be able to see the match object that was found while doing this operation, right? So suppose you found this match object. So there are certain things that you can do with this match object. You can say m dot start gives you the first index where it begins. M dot end 8 gives you the last, or you can do m dot span as we saw this. It tells you the exact span where this pattern is present. And then you can say m dot group on this match object, and it will tell you the pattern that was found. And this is the very first pattern that was found. So suppose, so group is the function that I initially showed you that we have. It's an important function that we are looking to deal with. That is the group function, but I'm going to go in a little deeper here. Let's do this pattern again. Suppose you have verse again. Suppose this string has universe and universe like that. So when you do this, once again, the m will find the very first pattern here. It starts at the index number 4 and it ends at the index number 9. So if you do m dot group, the group will tell you the pattern that you have found here. The difference between the what is the second function? The find all function that I was talking about. So let's look quickly into the find all function as well. The find all is fundamentally different. That if you do find all and you pass, let's say, the same arguments here as well. I think the syntax should be same. Oh, my mistake. What am I doing? It's re.findAll, not m.findAll. So so my mistake was I was calling this on m. So m is the match object. You don't find all on that. So basically regular expression, just like we did regular expression dot search here. If we do find all on that find all method and we give it this pattern to be found, then this returns a list. So important distinction between the search and find all. Okay, let's keep that tracked somewhere. So you have one method is search. This returns a match type of an object. And the other method is find all. This returns a list. The list is the list of all the patterns. So pattern 1, pattern 2, whatever were found in this search. This is that list. So in this case, for example, you found verse twice. So this is the 2 verses. So that's what find all does. Okay, so let's just quickly look into this again. So you have re.search. And if you do, let me just get rid of this. And then you have re.findAll, which gives you the list of all the patterns conforming to this pattern present. So once again, at this point of time, I've not used any pattern. I'm using hard-coded search text at the moment. So you're not able to see the power of regex right just yet. And the next section, I'll start talking about this. But if you want to try now, you can try this yourself. I'll give you a minute. Just do an import on RE, and you can just try all of these operations yourself.
So when we do the find all, it's going to give the search verse, but it doesn't give the index, right?
It will not give you the index.
So it's always going to be the same thing in the list.
Yes.
Okay.
It's all the patterns that have been matched. Those will be returned in the form of a list.
Is there a way to find all the occurrences along with the indexes?
We can programmatically do that. Yeah, we will see that later on.
Cool.
The assignment has a lot of occurrences that we'll have to find.
Also, you mentioned there are three options, right? Search, find all, and there was a group, if I'm not mistaken.
So group I showed you, you call group on the match object.
And that gives you
the exact pattern that is matched.
No. So group has to be called on match object.
Yes, the group has to be called on match object. Yes, that's correct.
Thanks.
But when we do the find all, the list would always have the same element then, right? It's a list of the same search pattern. Is it the case?
I did not get your question. So whatever matches in this string, those patterns will be. So let's say if this was a line containing emails, then all the emails that will match will be returned as part of match all object, find all object.
So my question is, the verse is the search pattern in this case.
Right.
So I thought whatever the search pattern, the list is always going to have the list of those.
Yeah, the list will always contain verse in this case. That's correct. Because that is the search pattern.
Right. Okay. So when we do email address, we can find something before the @ symbol.
Yes, I will show you how to write that.
Okay. All right.
All right, let's move forward. So a word of caution before we begin. The match object, we have to be careful. As we saw, if the search does not find anything, it will return an none match object. And if you cannot call anything on none, as usual, you're going to run into issues. So let's write a function, okay? And suppose the function is func, and let's say accepts a pattern and a source. And we want to search the pattern in the source. Okay, so suppose that, and we want to maybe return something with the pattern. So suppose, let's say we want to add an exclamation point to the return pattern. So I'm going to write a function. I'm going to say import re, and then I'm going to say, okay, re dot search pattern comma s, and let's say this returns m, and then I'm going to say the result is equals to m dot group, and then I'm going to say return result plus an exclamation point. So suppose this is my function. Now I'm going to call function with, let's say, two strings, verse comma universe, and I'm going to print the answer of that thing. Okay, so let's run this, and we have, you see, the verse and the exclamation point return. Now, does anybody see any problem in this code? This code has an unhandled error, and the error is that we are very, without really caring about this, we are calling m.group. There is a chance that m can be none because this pattern may not be found. Suppose let's change this to, let's call this function before this, and we say verse 1. Now when we run this, there's going to be an error in our code. And then error is that the none type object has no attribute group. So that means this error essentially is saying that we have called an attribute group on a none type. And this clearly tells you that this is the line number 5 where you're having the issue. So what we need to do is we need to check. We need to say, okay, if not n, okay, if n, then only do this. Else you need to do something else. You may need to say return or raise some error. You can say maybe whatever, raise an error or just return, let's say, something not found. For the simplicity, I'm just returning a string. So now your problem, this will not fail. But you have to be careful about this. You can either do a try catch type of a state, try and accept type of a statement where you try to do an m dot group, and if there's throws an exception, then you catch it in the error block and you do whatever you want to do. Or you can do this. This is very simple. And instead, if you want to raise an error, you can just raise some kind of an error. You can just raise some error. You can just whatever, and then it will raise that exception. So keep that in mind. This is important word of caution. When you're working with regex and you're matching something, always check whether the match was the match found or not before calling group on it. Otherwise, you'll be in a problem. All right, so now we are going to jump into the, actually it'll take 30 seconds if you want to try this out yourself. Okay, and then I will jump into the patterns. All right, so now we start talking about the patterns. Now comes the real regex part. We have formed some foundation of what search function is, search method is, find all method is, group is. Now let's begin with the real regex part. So regular expression is actually a very complicated language. It's not something simple, and it is very dense as well. If you have seen regular expressions in past, or if you have dealt with it, you will know that, I mean, a small pattern can be very heavy to interpret. So it's a lot of information gets packed into very small space. So you have to be very careful while writing a regular expression. Even something as similar as an email address has a pretty complicated regular expression. If you go to like some websites, Stack Overflow or whatever, trying to look for regex, you'll see that it's going to be very uh, pretty hefty regular expression. And in order to practice regular expressions in a very simple way, there are tools. You can search for Python regular expressions, whatever, online, and there'll be a bunch of tools that you can use to try these things out, which are really, really fast. So essentially, you can put your test string, you can put your regular expression in here, and it will give you the answer. Suppose you put this is the test string, and let's say you want words here, then essentially it will tell you that what was the regular expression that was found. But we will use this as we move along, because this makes life a little simpler in the real world situation. So patterns, let's begin with the patterns now. And the very first pattern I want to talk about is the dot pattern. Many of you must have used the regular expression, so this might look a little boring, but just bear with me. The very first pattern is the dot. So what is dot? A dot is, in the world of regular expression, a dot pattern can match anything except a new line character. So this will match anything except a new line character. So if I was to say, if I just go back to this previous example, and I was to just write, let's say, a dot here. This dot has a special meaning. We are not saying that we want to search for a dot at the moment. We are saying we are looking for a regular expression. This is our regular expression, and we're looking for a pattern that contains anything but a new line. So essentially that means that anything but a new line. So this will match on the very first object, very first letter, which is U. It will match that in this case. If you were to write, let's say, two dots here. Okay, let's just change this and let's write two dots. Then this will match the first two elements. Now, how regular expression gets formed is basically when you say, let's say, you want to match something, let's say something, then a dash, and then something. So now this dash is a literal text. You're saying you want this type of pattern that has a hyphen in between, and then anything on both the sides except a new line. So what do you think will match in this case? Can anybody tell me?
I dash V.
First
Yes. Yes, correct. So I dash V gets matched in this case, right? Because this is not a new line, this is not a new line, and then there's a dash in between. So the dot pattern is very important. It will match anything, one character at a time. It will match that. So that's the dot character for you. Let's suppose you are saying this type of pattern. Suppose you are saying that we want to match 4 of something, then an underscore, and then a dot. Then what will match in this case? What will match is this one, this pattern, most likely.
ERSE.
Yeah, ERSE dash V, right? The reason is because the first pattern has only 3 letters. So this is not going to match.
Is this like a question mark in the DOS?
Yes, you can put
world?
question mark. Yes. We will cover. Don't worry. There is different patterns that we'll cover as we move along, like star plus question mark. So this is the dot pattern, okay, and it's called basically just you just use a dot. Now, if you're specifically looking for a dot, then you have to change this regular expression and you have to tell Python that you are specifically looking for a dot by adding a backwards slash. So in this case, now nothing will match. Whenever you use anything in Python, which is, let's say, when you use the regular expression language and there are certain things, certain characters that are going to match a pattern. For example, dot is going to match a pattern. But what if you want to search for a dot? What if the dot is the thing you want to search? Then you escape this first, saying that whatever is following, do not interpret the special meaning of it. Use it as the string pattern. So when you want to do that, then you will specifically look for that. So then it will not match anything in this case. So we'll do plenty of these as we move along. So that's the dot pattern. Now, we're going to go a little bit back into the regular expressions. How do we do regular expression in hard way, but that gives you more granular control versus an easy way. Okay, so let's begin. The next pattern. The next pattern is called the word character. So what is a word character? A word character is something that will match anything that is between this range of A to Z, A to Z, 0 to 9, and underscore. Now, this is how you also specify range in regular expression. This is how you specify range. So suppose that in the previous example, I'm going to do a very the old way first, but this gives you more control. So let's say if you want to say, I want to match one character. So now square bracket has special meaning that we are looking for one character here, which can be anything between, let's say, an E, let's say E to F. So when we do that, the first E will be matched. So yeah, you will do that. So E to F like that. And that will match this particular range. Or you can just say maybe something you're looking for, let's say R to Z, then the whatever this V will be matched, the first V will be matched. So you can specify the ranges like this. Let's try an example. Suppose I'm going to say I want to match all of this, A to Z, 0 to 9, and let's say underscore in a target string, which is, let's say, something like this. Then the answer is none. We are not going to find this, a one character which belongs to this range inside this target, inside this source. So essentially, the word character in Python that I mentioned replaces this search with a /w. So this thing here can be replaced by one character called /w. So you can just look for that. You can say, you come back in this search and you can say find one character. In this case, when you say W, the W/W has a special meaning in this case. So you're saying that interpret this W not as the pattern, but we are looking for a word character. So nothing's going to be found. But if you had something here, let's say A, then that A will be found in this case. That is the first word character present in the string. Or let's say you had a underscore, then that will be found. Or let's say if you have a number 9, then that number 9 will be found in that case. Similarly, if you had this pattern, let's say you had this pattern going on, and suppose you had A, and then you had some more of this, and then D9, something like this. And if you run find all on this now, then you might have guessed what will come back. All the word characters have been found in this particular text. I'm going to give you a minute. If you want to try this out yourself, take a minute, try it out, and then we will. Any questions on the digit part? Okay. Then we have some simple things. We have
question. Sorry. So in this IP address case, we should be able to do something similar to the word, right? Like 0 to 255, like a range.
That might be hard to do. We cannot simply do that. If you notice, when this IP address is expressed in the form of a string, let's take this IP address that we had here. When this is expressed in the form of a string, then you'll have to match this character, then this character, and then this character. You cannot get the whole thing in one shot. And there are multiple combinations here. So this one can only go from 0 to 2, or it actually can go from 1 to 2 only.
1 to what? It can go higher than 2.
It can, the first digit can only go from 1 to 2, right?
Yeah, right.
The second digit can go from 1 to
0.
Yeah, sorry, 0 to 9, correct.
Yeah.
Right, and third digit can also go from 0 to 9, but that is also not that's straightforward. What if the first octet is 10? So it's a 2-digit number now. So you have to think about this, that it might not be 3-digit, the IP address. It might be 10 dot something something. So there are multiple cases to be considered, and this as we move along, we'll build this knowledge. So the third pattern.
You also have to consider whether it's a private network.
Yeah, I mean, yeah. I'm not concerned about the private or public network. I'm just concerned about like it's a valid IP or not in the end. Yeah, some form. The third pattern I want to talk about is a space. Matching any space in the document or in the line is a backward slash small s, and then opposite is a capital S. Any type of space you want to match in a pattern, you can do this with a backslash S. So now S has a special meaning and it's looking for a space. So right now there is no space here. But if you were to have some kind of a space, then you will match that. So slash T means that there is a tab in between. Or let's add different type of space. Suppose you have this and you have this. So now notice the number of spaces that have been matched in this case. So slash T was matched because it is a space. And this was matched 2 times because this is both in a space. And this was also matched. So you can look for all these spaces in this way. Or you can match.
Is there any way to use the hexadecimal values for those things, like 12 for space, or maybe that's new line, 20 is space?
I have not tried that. I'll have to try that. I have to try that. Yeah, I've not tried it, but it's an interesting question. It must be. I mean, people should be able to do it because hexadecimal is a pretty popular format. But I have not tried it. I'll keep that a note for myself, and then we'll get back to this. The opposite of this is the other, that anything that's not space. So this will match anything that is not a space. And as you might be seeing as we move along, that these things have to be used in combination, in conjunction with each other to get a final answer. You might be looking for something that is not space, and then you might be doing further searching that with something else. So small s is anything with space, any type of space, and this is anything that's not space. Now we want to come to 3 important things: the repetitions and 0 or 1. Okay, so first let's come with the repetitions. The first repetition that we have is plus. Plus means 1 or more. Okay, so let's try this out. 1 or more. So let's go here. Let's look for a better pattern. Okay, let's come here. So when we did this, we got whatever this pattern was. Now, if you want to say 1 or more of word characters, then we can just say /w plus. So this will give you, this is going to be a greedy search of the biggest possible string which matches this from the start. So the first string that matches this is U and I, right? This is 1 or more word characters together. So this is where it will match. And if you want to do the same thing with find all, you might have guessed the answer. It's going to return a list of 3 separate strings which satisfy this condition.
So if you want to find just 2 characters instead of like UN, then should we put like /w and dot?
What are you looking for? First, tell me.
So when we put a plus, it's looking for more than 1. But if I'm curious to get just 2 characters.
So then you put /w. Then this will give you 2 characters sequences. If you do this, okay, let's say if you do this dot, then what will be the output? Tell me. What will this match? This will match a word character and anything which is not a new line, right?
Okay. Okay.
Yeah, so what all it will match UN, NI, I dash, right?
Okay. It's like a wild card character, right?
Right.
Okay.
There is something more that we'll talk about in future, how to match specific number of times, but we'll talk about it later on. Okay. So that is the one or more. Okay, that's keep that distinction in mind. That's one or more. Okay, at this point of time, I'm going to take once again a minute break. I want you to try this sequence out. You can try different things. Okay, suppose that there is a line of text that contains year. Okay, in the year 1990, whatever, I went to SF. Later in 2001, I went again, and then it has some number, suppose 899, for some random reason. Let's say we want to find out whether this string, okay, I'm talking about in a very raw form. We just want to find out whether this string contains any years. And if it contains years, what are those years? Then can anybody write pattern now based on what we have learned so far? Don't worry too much about don't worry too much about the validation on the year. That year has to be one, starts with one, ends with two. Just very generic. Any thoughts on this?
What was your question again?
So if this was the line of text and we want to find out if it contains any years in it, and if it contains, then what are those years, then how will you find that? What pattern will we write?
Square bracket 0 to 9 plus
0 to 9
plus.
plus. Is that the pattern? So let's do re dot find all on this pattern. Okay, I'm intentionally doing re find all because we will find everything then and line. So we get this. Is that correct?
Well, as long as 899 is a year, you can, of course, this should be right.
Yeah, I mean, so year generally, for example, let's consider that year is 4 digits. So what we can do is we can write something like, will this always give you year? Maybe not, because for example, 9999 is not a year at this point of time, but I'm saying just relax that constraint. Don't worry about it at the moment. But you can see that when we began the conversation about talking about the regex, the very first example that we took was this example, that we can check a particular pattern in present in a target. And then we can also find out where that pattern is present in the target. But here the pattern was very hard coded. Now we have literally said something here, which we did not know really exist in the string or not. This is our very first example in which we found out whether the years are present inside a line of text. Right? Any questions? Okay. The last pattern the second last pattern that I specifically want to discuss is the 0 or more pattern. That is also a very important one. It is almost similar to plus with one small difference, 0 or more. Asterisk, 0 or more patterns. So if I was to just look for this, what do you think the answer will be in this case? When I run this, notice what the answer is. And can we guess why this answer is like this?
Because it is 0 or more.
It's 0 or more. Correct. 0 or more. So we have to be careful about what patterns we use. So asterisk, essentially, it is useful, and we will see in examples how we use it as we move along. But based on this information, if you think you combine two patterns, let's say I take the pattern dot and I take the pattern asterisk and I look for dot asterisk, what will it match?
Everything?
That's pretty much right. We are saying 0 or more occurrence of anything. So it matches everything. The entire pattern is going to match. So 0 or more of anything which is not a new line. Right? So this search pattern will match everything in that case. So if you were to do an dot search, then this is the whole pattern has been matched in that case. Does it make sense?
So when we have multiple lines like a log file, then the dot would be helpful, right? In this scenario.
Yeah, then in the case, the dot will be helpful.
Okay.
Let's try an example. So suppose we have, let's say logs is equals to, let's say, ABCD / n, this, / n, and this. And let's say when you print logs, then you have this. Now you do search of this in the logs, then you will match the very first 4 characters. So anything that is not a new line will be matched with this. So that's a pretty powerful pattern in that way. Dot star is going to match everything that's not a new line. So your entire line essentially is going to be matched.
That's cool. Yeah.
So when people are dealing this in the Linux, you must have used this a lot of time while doing some kind of a search inside the file or something. These patterns get used all the time in working with operating systems. Dot star. So let's try to build based on our knowledge so far. So far, our knowledge is about these things. Let's try to build a regular expression for an email, a very basic type of an email. Okay. Suppose I am saying that I'm going to allow following things in my email. Let's first contains a text. Let's say text. Okay. And suppose that text contains some email address. Okay. This line contains emails like, let's say, himanshu@yahoo.com, sam@gmail.com, and let's say frodo@hotmail.com, and some other random text strings like let's say abc@def, and let's say 12 at. Okay. So I've intentionally kept a whole bunch of different things in this. You can notice that some of these are email, some of these are not email. So now we have to come up with a regular expression that matches email addresses in this. Okay. So what do we know about an email address? What are some of the things that we know about email address? Can we talk about this? Can anybody tell me?
It has to have an @ symbol.
Right. So first thing is that it has to have an @ symbol. Correct.
And it also has to have a dot to separate the domain
Right. Correct.
and the com, or
No.
the domain,
Many optional.
the dot domain and the
There's a .org.
top level, and you can
That's
have
correct.
many sub-level domains.
Right. So the domain will contain a dot. So the email will be of So here the some string at something dot some domain.
You may also have a string in this, a dot in the sum string.
Yes, so that's also an important point. What is this sum string? This sum string, each character here can be what? It can be an A to Z,
0 to 9.
0 to 9, underscore, and it can be a dot as well, right? But however, there are some constraints here, okay? We are not going to go into detail. For example, an email cannot start with an underscore. It cannot start with a dot. It cannot have two dots. So there are some constraints. But we are holding back at the moment. We're just constructing, let's say, a basic email address. So how can we do this now? What can we do here to match this thing?
First search for anything in that first set you have there. Although I would search for anything except that dot in that first string.
Okay, so let's begin with, let's say, re.findAll. I'm specifically using find all because it will give me everything that I'm matching. This is my search pattern, and this is the text is the target. So let's just first put at here. If we put at, then it will match all the ats that we have in this string. So it is a starting point. It is rejecting everything else. Now, what do we know about this? We know that it will have some kind of a word character before, right? And it probably will have some kind of word character after. So we have something here. What we also know is that it might have one or more word character, right? So we can say one or more word character and one or more word character here. Pretty good, right? We're making decent progress now. We can say that Himanshu at Yahoo, Sam at Gmail, and we got something, and it automatically eliminated this 12 at. But it's not, we have not yet eliminated this guy because we still can have a dot. So we know that there will be a dot, but we cannot put a dot because that dot will essentially will mean match anything. So we want to say specifically match a dot. And then we're going to have some more word characters. Pretty neat. We are getting there, right? We are getting there. But what if there are some more type of email addresses here? Suppose you have this, and suppose you have Nick. Suppose you have, let's say, hey, whatever, him.sh at whatever, gmail.com. And suppose you have whatever, him underscore sh at yahoo.com. Let's run this again. So it is matching this guy here, right? Him.sh. So we have to be careful about this as well. And this is your assignment. Okay, take this text and try to come up with this regex. Okay, don't be too specific. Okay, I don't want you to consider this case because once again, I'll tell you, writing regex for email is actually not a trivial job. It's a pretty complicated stuff. Don't worry about this thing, that whether this is starting with a dot something. Don't worry about this case, or sorry, something, or don't worry about this case where you have sam dot whatever what's at gmail.com. Don't worry about these cases, but just come up with some kind of a regex that covers an email in general. Okay, and you can post your results to the Discord, whatever, post your regex to the Discord. I'm going to put this, and I want you to work on that. We are over the time already. In the next class, I want to start with this email regex to begin with. Then after that, I'm going to go into some more thing. I want to go into the raw string search, command line arguments, and show you a bigger assignment problem that we have for this particular session. All right, so with this, I'm going to stop the recording. And if you have any questions,